On page 433, we get a new formula. We can highlight some stuff. Right here, in certain measurements that have a very huge scale, a logarithmic scale is used because you can shrink it down because everything's based on powers of 10. So some examples, and we're going to look at the Richter scale first on your take-home assignment. You've got a question that involves a pH scale. Decibel scale is another one. These are all possibilities that they could put a formula like this on your exam. So the Richter scale formula is right here, and it says that the magnitude of an earthquake is equal to the log of the intensity compared to the intensity of a standard earthquake. And what a Richter scale does is every time you go up by 1, your earthquake is 10 times more intense. So when we look at the first example here, it says the most intense earthquake ever recorded was in Chile with a magnitude of 9.5. Calculate the intensity in terms of the standard earthquake. So if we're just using the formula for A, you would again be given this formula that the magnitude is equal to the log of the intensity compared to the intensity of a standard earthquake. And each of those things would be defined for you. If we're told that the magnitude is 9.5 and you want to solve for I, we have to say, how do we solve for something inside of a logarithm? What did we do? Do you remember the steps? Because I find this is the one type of solving that students forget the steps the easiest. I'm not sure. So right now, we've done this before. How would you solve for I? What would you do first? We could do log I minus log S, and then that would get us 2 logarithms. Okay, that's one possibility. But how do we get I all by itself? How do we solve for something inside of a logarithm? We'd have to go, sorry? No, nothing? I thought I heard something. Could put it into exponential form. Right? That was the key step for solving inside of a logarithm. Number one, you needed a single logarithm. Do we have a single logarithm? Yes. Log of something equals, we have a single logarithm. Once you have a single logarithm, you can change it to exponential form. This next step is the one that I said you always forget. 10 is the base, 9.5 is the exponent, is equal to I over S. Now, if you wanted to get I all by itself, you could multiply both sides by S. 10 to the exponent of 9.5 times S is equal to I. And right now, if we look at what the question was asking, calculate the intensity. So we have intensity equals. In terms of a standard earthquake, do we have the standard earthquake in there? Yes. In other words, the intensity was 10 to the 9.5, which is a huge number, more intense. How many times as intense as the Haiti earthquake? And the Haiti earthquake was given in the question beside, which had a magnitude of 7. How many more times as intense was the Chilean earthquake compared to the Haiti earthquake? So in B, and I'm going to put a little C beside that because that's the intensity of the Chile one. Could you see that for B, if you wanted to find the intensity of the Haitian earthquake, you could do that the same way, and you would get 10 to the 7.0 times s. And when you want to compare how intense one is compared to the other, you just have to divide them, right? How much times bigger is something than something, you would divide. And so if I take the intensity of the Chilean one and divide by the intensity of the Haitian one, I would get 10 to the 9.5 times s divided by 10 to the 7.0 times s. What would the s's do? They'd cancel out. And what exponent rule do you have when you're dividing and you have the same base? Subtract. And so sometimes, and it is accepted as a proper technique for earthquakes, you would just say if it goes up from 7 to 9.5, it's going up 2.5. That means it's going to be 10 to the 2.5 more intense. If it goes up 2, it's 10 times 10, 10 squared more intense. So you could just divide 10 to the 9.5, divide by 10 to the 7, and get 10 to the 2.5 as your answer. So earthquake questions are sometimes seen as really easy because you have that shortcut. Right? If I was comparing an earthquake of 6 to an earthquake of 7.4, I'm going up 1.4. It's 10 to the 1.4 times more intense. And I wouldn't even have to use the formula to do that. So that's kind of nice. However, you will need to use the formula if you're solving pH scale questions or decibel questions. In those situations, you need to know how to solve a log equation. And solving a log equation means you have to get a single log and then use the definition to change to exponential form. That's the key thing. Okay. Questions for practice 4, 5, and you have an earthquake question on your take-home quiz 9, 10, and 11.